The James Webb Space Telescope is the largest optical telescope in space. It took a record 30 years and $10 billion to construct it. Although it's only been in operation for about a year, it regularly produces breathtaking images. But the main goal that its creator set was of course not just taking impressive photos, but generating data that would confirm the Big Bang theory. However, immediately after it started to transmit data to Earth, articles about the discoveries that do not confirm but rather contradict the Big Bang theory began to appear. In particular, one article with the title "The Big Bang Didn't Happen" by Eric Lerner has become extremely popular on social media. Lerner makes a number of highly provocative statements about the fact that the new data is causing panic among Big Bang supporters and that the existence of a number of newly studied galaxies suggests that the Big Bang did not occur. So what's really going on? What are these new discoveries about? Do they undermine the Big Bang theory? Are its supporters really discouraged by what the James Webb Telescope showed? Some concepts in astronomy have existed since ancient times. Others have appeared quite recently. For example, people came to understand that there are other similar galaxies outside the Milky Way only about 100 years ago. Only a few galaxies can be seen through a telescope, though we will see only a faint spot. Thus, even in the 20th century, most astronomers considered these objects to be simply gas clouds within the Milky Way. It was believed that our galaxy was the only one. In the 1920s, Edwin Hubble showed that the Andromeda galaxy must be outside the Milky Way. Over time, more and more astronomers recognized that these islands in the universe were extragalactic, that is, outside our galaxy. Astronomers knew that galaxies may be in all sorts of shapes. As early as the middle of 1920s, Hubble began to classify galaxies according to a scheme now called the Hubble sequence. According to this classification, there are elliptical, spiral, and irregular galaxies. Elliptical galaxies are on the left. They are large and round, ranging from spherical to ovoid. Spiral galaxies, shown on the right of the diagram, are flat, disc-shaped with spiral arms and central bulges. Some of these are barred spirals, each with a bar between the bulge and the arms. By the way, our Milky Way is considered to be a barred spiral. Some astronomers also consider lenticular galaxies to be a separate category. They are in the middle of the sequence. They have large bulges and flattened disc shapes, but no spiral arms. And finally, irregular galaxies are those that do not fit into other categories. They tend to be asymmetrical and, as the name suggests, are rather irregular in shape. Now that we know these basic varieties, we are ready to move on. It may seem that the Hubble sequence shows evolution over time, and according to secular astronomers, this indicates that galaxies supposedly evolve from the shapes shown on the left to the shapes shown on the right. But this is wrong, and Hubble himself noticed that this was not the case. Today, most evolutionary astronomers actually believe that small irregular galaxies formed first, then they merged to form disk galaxies, and then, over time, disk galaxies merged and united into elliptical ones. Another common misconception is that this process was supposedly the result of the Big Bang. In fact, stars and galaxies must have formed later. Therefore, if the general history of the Big Bang is correct, then when the universe was formed, galaxies did not exist, and this had to be quite a long process. A little bit later we shall discuss this in more detail. Then there was an era when galaxies were just starting to form, and over time they turned into the galaxies we see today. So, if we could somehow look back in time, then throughout most of the history of the cosmos we would see the same mature galaxies as we see today. But if we kept looking further and further into the past, we would eventually see the era when the very first galaxies were being formed. In other words, if the Big Bang model were correct, and if we could look far enough into the past, we would see a universe dominated by immature galaxies that by today's standards would look strange. As telescopes improve, we can really look deeper and deeper into space. From the perspective of the Big Bang, this would mean that we are actually looking back in time. Here, for example, is a famous photograph called Hubble Deep Field. The galaxies in this photo are so far away that we see them as they were 13.2 billion years ago. In other words, the light they emitted took 13.2 billion years to reach our days. According to this logic of evolutionary astronomers, as we look further and further into space and thus further and further into cosmic history, we should see more and more irregular galaxies. For many years, this seemed to fit the expectations of evolutionary scientists. However, as it turned out, everything was not that easy. Over the years, astronomers have developed extensive models of how galaxies will form and evolve over time. By the early 2000s, it became clear that it would take 3 to 6 billion years for galaxies to form. This means if the Big Bang model is correct and our telescopes can look deep enough into space, it would be possible to see the light from the earliest galaxies. In other words, we would see these galaxies as they were when they were being formed. But to see these, how deep do we have to look? According to the Big Bang model, the universe is almost 14 billion years old. So, if we could observe galaxies at a distance that is a look back 8 to 11 billion years, then we would see the universe as it was when it was only 3 to 6 billion years old. This is not easy, but it is quite possible with the modern equipment, and by the early 2000s, astronomers were already regularly observing objects at such distances. But have astronomers seen the universe where galaxies were only beginning to form? No. Instead, as the astronomers looked further into space, at this mind-blowing distance, they could only see massive mature galaxies which, according to secular models, should not exist, since, according to the same models, there would simply be not enough time for the formation of these galaxies. Nevertheless, they exist. Back in 2004, the Gemini Deep Survey was published, in which British astronomer Carl Glazebrook, known for his work on galaxy formation, commented,
"We expected to find basically zero massive galaxies beyond about 9 billion years ago, because theoretical models predict that massive galaxies form last. Instead, we found highly developed galaxies that just shouldn't have been there, but are."
In the study of 2005, the Webb Space Telescope was used, and the astronomer Jiaxin Huang from Harvard Smithsonian Center for Astrophysics commented the results.
"We're detecting galaxies we never expected to find, having a wide range of properties we never expected to see."
Ivo Labbe, the astronomer from Carnegie Observatories, remarked,
"We are really amazed. These are the earliest, oldest galaxies found to date. Their existence was not predicted by theory."
We'd like to emphasize one thing. According to the Big Bang Theory models, massive galaxies should not have existed more than 9 billion years ago. This is only about 5 billion years after the supposed Big Bang, but it would take about 6 billion years for galaxies to form. However, massive galaxies were also found at greater distances. But despite all this, there was some good news for evolutionary scientists. As we mentioned earlier, most irregular galaxies were found at these distances. So, even though there should be no massive galaxies, the presence of at least a large number of irregular galaxies was quite in line with the expectations of Big Bang supporters. But then, at the end of 2021, the James Webb Space Telescope was launched, and everything changed. The overall diameter of the James Webb Telescope mirror is 6.5 meters. This gives the telescope a light collecting area about 5.6 times larger than that of the Hubble telescope, with the 2.4-meter diameter of the mirror, with the collecting surface area of more than 25 square meters versus 4 that of the Hubble. In short, its optics is many times more powerful. Some of Webb's early tasks were to monitor the objects and areas that had already been depicted before. Here is an example. The image on the left was taken by the Hubble Space Telescope and the image on the right was taken by James Webb. Obviously, Webb gives excellent results. Note that Webb not only gives more detail, but also shows objects that were not visible before. It turns out that many of these areas contained many more galaxies than it was previously known. They were too faint to be seen with other telescopes, but Webb can see them. The vast majority of these newly discovered galaxies are not irregular, they are disk galaxies. Moreover, some of the galaxies that were previously thought to be irregular turned out to be disk galaxies due to high-quality images. For example, according to the study, there turned out to be 10 times more disk galaxies than previously thought. About half of the observed galaxies are disks. Remember that it was earlier considered that it was irregular galaxies that dominated at such distances. These regions should have attested to the early stages of galaxy formation, but Webb has shown that this idea is erroneous. Now we know that there are many mature galaxies in these regions, even if according to the secular point of view we look far back in time, much earlier than the time when the existence of galaxies was considered possible. So we see that Webb's images of already studied regions refute the ideas of the Big Bang theory. In addition to this, the James Webb Telescope was designed to work in the infrared, to look even deeper into space than other telescopes. More distant objects have a higher redshift, which means that the spectrum of their image will be shifted from the visible range of the infrared. Therefore, Webb was specifically designed to observe high redshift objects. Thus, from the point of view of astronomers, Webb can see objects as they were much closer in time to the supposed Big Bang. Given this circumstance, a natural question arises. Observing the most remote regions that were previously inaccessible, did Webb manage to identify that stage of the universe when it was full of immature, still forming galaxies which secular cosmologists expected? No. Webb's deepest images still show massive mature galaxies. In other words, even at the earliest stage of cosmic history, mature galaxies already existed. How early? Currently, mature galaxies are being reported which, according to secular models, were formed only 230 million years after the Big Bang. Despite the fact that just a few years ago astronomers believed that it would take at least 3 and possibly up to 6 billion years for the galaxies to form. Now they have to deal with Webb's observations of galaxies that, according to their worldview, existed just a $250 million years after the Big Bang. And this is only 8% of 3 billion. In other words, Webb shows galaxies that from a secular point of view already existed more than 2.75 billion years before they should have appeared. It's total inconsistency. Although from an evolutionary standpoint this is shockingly early, the problem is even worse. At that time, these galaxies were not only being formed, but were already formed. This means that the actual formation process must have taken place much earlier. Further research has found many other inconsistencies with the predictions of evolutionary cosmology. Here are just a few of them which are easily understandable even to a person who is not savvy in this area. Evidence of an even larger formation has been found. Some of the galaxies have approximately the same redshift, indicating that they are a connected group of galaxies. Simulation models predict that this structure cannot emerge immediately because it takes time to form, but in these images it is already fully formed. Many of the distant galaxies are quite bright. Some of them are comparable to or are even brighter than our Milky Way galaxy, so they are no less mature than our galaxy. Many of the discovered galaxies are quite dense. As noted in this study, in some regions the stellar mass density is 3 times higher than anticipated. In other words, the density of stars in some of these galaxies is more than 1000 times higher than the expected value. They are chemically mature. For example, in the area explored by Webb, there is an astonishing wealth of elements such as oxygen. But if the Big Bang model is correct, to make it possible, at least 2 generations of stars must have already been formed. The thing is that the Big Bang model says that the explosion couldn't have produced anything other than hydrogen, helium, lithium, and possibly trace amounts of beryllium. So the model says that for heavier elements like oxygen to exist today, stars must first have been formed from hydrogen and helium. They then burned for some time and produced heavier elements via nuclear fusion until they finally reached the end of their life cycle and exploded. Then new heavier elements were spread all over space. Only after all of this had happened could a new generation of stars form that could include new elements. Webb's images show galaxies that fall short of the expectations of evolutionary astronomers. And remember that Webb only operates for about a year. We are only seeing the results of the first few studies, which is only a small fraction of what will be discovered and published in the coming years. It is possible the mature galaxies will be found at even greater distances. In fact, it is reasonable to expect this, since there is no indications that we are approaching the supposed era of the initial moment of formation of galaxies. As the astrophysicist and professor of extragalactic astronomy at the University of Manchester, Christopher Consolais, notes,
"We have not reached the limit of where the first ellipticals and spheroids have formed. We will need to probe even higher redshifts to find when and if there are no spheroids or disk galaxies."
But scientists are running out of cosmic time in which they can look for this supposed period of galaxy formation. As Webb looks deeper and deeper into space and thus, from a secular point of view, further and further back in time, there is less and less time after the Big Bang available for the formation of the first galaxies. This crisis of mature galaxies has been growing since the middle of 2000s, but now Webb is adding fuel to the fire. In the creationist community, many of us expected similar discoveries, but Webb achieved the results that were even better than we could have expected. So, could this be the last nail in the coffin of the Big Bang model? Does this mean the secular astronomers are panicking, as some articles claim? On the one hand, new observations do cause some confusion in the secular scientific community. For example, it is interesting to note the following quotations from evolutionary astronomers published in the media.
"The models just don't predict this. How do you do this in the universe at such an early time? How do you form so many stars so quickly?
Reality simply drives us crazy.
No one was expecting anything like this.
Right now, it's 3 a.m. I'm awake wondering if anything I did was right."
Yes, the quotes are impressive, but it is worth noting that they only show that these astronomers do not understand how their models of galaxy formation can fit with the new observations. But this doesn't mean that they question the Big Bang model itself. It may seem strange that evolutionary scientists are not responding appropriately to this data. With very few exceptions, secular astronomical community accepts the Big Bang model as fact. Most scientists do not question this model because it doesn't even occur to them. And it seems that the idea of the Big Bang has been granted a mandate of immunity and will not be abandoned under any circumstances. But will the James Webb observations force us to rethink models of galaxy formation, early star formation and others? Yes, definitely so. In fact, this process has already begun. Webb's observations are so inconsistent with secular expectations that it seems logical to question the larger Big Bang model that gave rise to these expectations. But as practice shows, even such shocking results of Webb's observations will probably not be enough to refute the cosmology of the Big Bang. Previous discoveries have already falsified this model, but unfortunately, this did not change anything. Let's look at a few such examples. The Big Bang model violates the laws of physics. Either something came from nothing, which violates the law of conservation of matter and energy, Or there has always been something that violates the second law of thermodynamics, which indicates that in some finite time all useful energy, suitable for doing useful work, must be exhausted and the universe will go into a state of thermal death. But we see it as a living universe full of useful energy. In any case, the Big Bang theory goes against the laws of science. The only cosmological model that explains our universe and is also consistent with physics involves the creative act of a supernatural creator. The Big Bang requires the introduction of an inflationary period. A completely far-fetched story about the inflation, a fictional particle completely unrelated to physics, which was invented solely to save the model from the evidence that would be fatal to it. The Big Bang requires the multiverse, an infinite number of universes. The Big Bang requires the multiverse, an infinite number of universes. This idea is not only unscientific, but also anti-scientific. But still, secular community accepts it, because the Big Bang model requires it to somehow explain the impressive fine-tuning of the laws of physics and the visible design in the universe. The Big Bang model requires dark energy, a mysterious anti-gravitational force, which is again beyond the frontiers of known, that was invented to protect a fundamental evolutionary assumption called the cosmological principle from being refuted by scientific data. Although Webb's findings radically contradict secular predictions about the formation of galaxies, these predictions will soon be modified to accommodate them. Compared to all the other fatal problems connected with the Big Bang model and all the tricks the evolutionary community went for to defend it, making new predictions of accelerated galaxy formation will be child's play. The continued support for the Big Bang model, despite the long list of discoveries that should have undermined it, shows us that it isn't a scientific model at all. Scientific models are discarded when there is evidence against them, but the Big Bang was immune to that. Scientific models are discarded when there is evidence against them, but the Big Bang was immune to that. That's because it is not really a scientific model. This is an ideology. It's an undeniable belief of the secular community. The James Webb Space Telescope was designed to give us a deeper insight into the universe. And already in the first year of its work, a lot has been achieved in this direction. Along the way, it relieved something else to us. Webb opened the void of modern cosmology of Big Bang supporters, and we saw the failure of most of the predictions. We saw a complete discrepancy between the observed data and the predictions of evolutionary cosmology. But most importantly, we see the universe exactly as the expected result of the creative act of the Almighty Creator, fully mature from the very beginning. As the Holy Bible says, the earth is the Lord's, and everything in it, the world and all who live in it, for He founded it on the seas and established it on the waters. Friends, thank you for watching. If you find it interesting and useful, help in sharing this information so that as many people as possible know the truth. Don't forget to subscribe to the channel and support our media ministry to help us create new videos. Peaceful sky to all of us. Hope to see you soon.